My name is Eric Masson. I'm a professor of chemistry at Ohio University. The interest of my research group is supramolecular chemistry. That means that we study how, why, and how tight molecules interact with one another. And because of that interest, we are going to be the engineers of a new nano vehicle that is going to be used or driven during the second Nano Car race in 2022. The first race took place in Toulouse in 2017, where the Ohio team, so me and Professor Hla from physics and astronomy, designed and drove a first prototype. And now we are coming with a new prototype for a new race.
This is Surface Science Lab. It's my lab, and basically this lab is designed for atomic manipulation. And we do have scanning tunneling microscope systems. Those are capable of moving individual atoms and molecules with atomically precise movement. We are not allowed to push the nano car with a tip. We have to use either electron energy or electrical energy. So when we design the nano car, we have included the charge locations. We call it the polar molecule. So the nano car has the receptors which can accept the charge. So if we use the electric pulse from the STM tip, electrical pulses, depending on the polarity, the car will either move forward or backward.
So to power the car, we're going to need the tip of a scanning tunneling microscope, and this is what Professor Hla from physics is doing. So scanning tunneling microscopy. So he will drive the car using the tip of the microscope, and he's going to do it here while being in Toulouse remotely. The first design was, I would say, a nano wagon. So we had like a chassis, and we had 4 cucurbituril wheels, so it looks like a car. And what we wanted to see in this new race is what would happen when you've got 2 axles instead of just 1. So we have the road, which is a gold surface. Then we would have here a first axle, and then on top of it, a second axle.
Gold has a special property. The gold 111 surface, we call it the herringbone reconstruction. Its atomic scale is a little bulky. So it's not entirely as smooth, it's just clean. Now the question is, some of the nano cars may not overcome those bumps. So we designed our car, a proper American car, bulky. We would drive through all these bumps. That's our plan, and we are going to win it.
I've got 2 graduate students right now working on the car. I'm also going to have most likely 2 undergraduate students working on the project, and very likely we are going to travel 2 graduate students to Toulouse.
This year we have 3 graduate students will be involved, and they are very important because they are the one who will prepare the sample. They are the one who are going to deposit the molecular cars, find the cars, to make everything ready. So they are going to prepare all these things here locally.
They work from scratch, right? From just atoms that they connect together to make a molecule. And then from the molecule, they make the Segway. And then from the Segway, they deposit the Segway on a surface. And then they drive the Segway on the surface. So it's basically from the whole process from A to Z until the finish line. And of course, they learn some new science. They meet new colleagues. For example, students in chemistry are going to discuss science with students from physics. So it's basically this, cross-disciplinary aspect that's also very, very important.
Science without the public outreach is nothing. The science is funded by the taxpayer money. We need to inform the public what we are doing. Of course, we are not driving the nano car every day. We are working on our science. However, this is the great opportunity to reach out, to inform the public, hey, we can do little nano cars we can drive. And also we can make public not just aware, but also interested in it.
Also what was nice is to see young kids, right, coming to and talk with us and say, oh, this is really nice. Can you explain how that works? How cool chemistry or science is, right? At a young age is really important. I mean, this is really how our world works. But then there is really the fundamental aspect of what happens when you have molecules interacting with other molecules or molecules interacting with surfaces. How do they behave? Do they slide? Do they roll? How do they move? How do they proceed? Because in a sense, I mean, life itself is basically just a ballet between molecules that stick to one another. And that's why we're basically alive. So understanding how the whole process works, I think, is extremely important. So that's what we're trying to convey here.